we have seen a lot of development around the idea of building agents which work on having a hierarchy of different language models in a system. And then we have this concept of mixture of experts, which is slightly different, but talks about building a language model that actually inside has smaller language models. This actually brought back the idea of the value of having this small language models, right? I think it's very easy to imagine that when you work with small language models, like imagine something with like 2.7 billion parameters as opposed to 175 billion, you can capture IP easier, and there is this stochastic, non-deterministic nature in large language models that kind of can be controlled so that the output could be more deterministic if the model is a little bit smaller, the network is a bit smaller. And also the idea of the cost, right? The cost of training these things are a lot cheaper, so a lot more people can participate in that. Particularly academia or smaller enterprises can now build these models that really capture their IP. A lot of good examples out there. I think the Gemini Nano is an example that talks about running on the device as well, right? SLM significantly save cost when it comes to training or even operational requirements. I think they require a lot less in terms of to run them correctly, and you can deploy them in a much smaller footprint kind of environments, and a lot of good pre-trained ones are out there which you can start experimenting with. Maybe pre-train them, maybe look at the way that they were. You can fine-tune them for your specific kind of work. And accuracy can get a lot better for well-defined smaller tasks. That makes them very good cases for customization, right? You can customize it to your requirement as opposed to use, for example, GPT-4 to summarize a specific document and then probably RAG. You probably can do something interesting building these SLMs. So they're really, I think it's a good idea to experiment with them at this stage. They have security advantages as well. Of course, it's easier to mechanistically explain what's going on for a smaller neural network as opposed to the larger one. And we see a lot of people experimenting in building domain-specific applications with them. I think the IP is the key, the intellectual property that these things can capture better. Another thing that might be a soft topic of discussion is, given that a lot of organizations have very clever assets in AI with AI ML background, these people are very good candidates in experimenting with SLMs as well. And the data quality issues that we have here, you can imagine if you have a very large language model, hundreds of billions of parameters, you have a lot more room to provide data that is not vetted. But if you are working with smaller networks, obviously the quality of this could be a subject of discussion. A lot of interesting things are happening there, and I think your AI ML experts could be a very good candidate of start experimenting with SLMs. I would say that there's a hype. Of course, there's a hype around them. Like a lot of other things that happen, like even the idea of agents. I think initially we had a bit of hype around auto GPTs and those kind of things. And there were some issues like looping in there. But it totally deserves investing time and resources to figure out what can be done. Just leveraging an API for large language model, I don't think will be sufficient longer run, because we want to build some sort of multi-agent environment, an agent that orchestrates different agents, and those ideally can have their smaller language models, which are much more secure because they have been built by your data and potentially they're running on your premise. So much less chances of leaking IP there. Very interesting development. I think you start investing in your teams to build an experiments with SLMs.